Great. Thanks, Amir. Hi, everyone. I was thought a good way to get the ball rolling is for everybody to utilize the chat function on your top left. So if you're comfortable, type in where you're calling from and the temperature in your city right at this moment. Preferably in Celsius, but Fahrenheit is okay as well. And we should be able to see some messages come through. So we can make a formal start. Good morning, good afternoon, and good evening to everyone joining us online. Thank you for being here for today's webinar, Digital Twins at Scale, from Vision to Operational Use. I've had the pleasure of moderating today's session. My name is Kevin He, and I'm a Client Solution Architect at XylemView, supporting business development and sales initiatives across the APAC region. I'm joined by a distinguished panel of guests who I'd like to introduce. Firstly, Pilar. Pilar Conejos is a water supply specialist and digital twin manager at XylemView. She's a leading expert in smart water solutions and digital twins, known for her work and experience at Global Omnium, showcasing how digital twins optimize daily utility operations. She's also an adjunct professor specialized in hydraulic engineering at the Polytechnic University of Valencia. Next, we have Asem. Asem Zabin is a transformational digital leader with over 14 years of experience delivering strategic solutions across infrastructure and utilities. Currently with GHD in the APAC region, his work focuses on advanced digital engineering, including BIM, AI, and data-driven asset management. He is also the SWAN code lead for Asia Pacific Digital Twins Working Group. And finally, we have Wouter. Wouter Huisman is a program manager at Brabant Water, where he leads large-scale digital transformation initiatives focused on smart, data-driven water operations. And with over a decade of experience in the drinking water sector and asset management, he is driving the Sophia program, which is the project being shared in this webinar, developing a real-time digital twin of Brabant Water's network. So this webinar will explore how organizations are moving digital twins beyond concepts into delivering real operational value at scale. As we walk through the agenda, you'll hear practical insights, regional perspectives, and a real-world example of how the Brabant Water digital twin is being applied in day-to-day water operations. And thereafter, we'll have some time for Q&A, and we'll conclude with a SWAN update from Amir. And please note that this webinar is focused on the digital twin of the drinking water network, and through SWAN, I'm sure we'll be happy to organize a separate session on treatment plants. So without further ado, I'll pass on to Pilar.
Thank you very much, Kevin, for your kind introduction, and thank you all for joining this webinar. In this first part of the webinar, I am going to speak about digital twins and network operations. So let's start. And the digital twin concept is not something new because it was introduced in 2005 by Dr. Griffiths, and it was first applied to the industry sector, and later this concept has been extended to other fields like water sector. Indeed, SWAN Digital Twin Working Group has been working for a long time trying to establish a common strategy to adopt this technology in the water sector. In this slide, we see the definition of a digital twin. I think it's a very good definition, and I have highlighted the main works that make this technology different. A digital twin is a dynamic digital representation of the real system, and it has to represent the assets and also its behavior. This is very important because we are going to need data and also models. And finally, the goal is to have the necessary insights in order to make decisions and to improve the behavior of the real system. So according to this definition, with a digital twin, what we can do is to monitor the entire system. This is very important because we can monitor the locations where we have sensors, of course, but we also can monitor those locations where we don't have sensors, thanks to the fact that we have simulation models that are running in real time and are calculating the parameters in the rest of the locations where we don't have sensors. As a consequence, we can analyze the entire behavior of the system, having a holistic view or a holistic approach. But we can even simulate the behavior of the system under any other conditions, hypothetical conditions, what we call what-if scenarios. That means, for example, that I can simulate what's going to happen if a drinking water treatment plant is out of service for more than 12 hours, or what's going to happen if a big or important pipe, or I have a burst in an important or a main pipe. And finally, with all this data, what I have is insights in order to make decisions in the real system. For example, what is going to be the pumping schedule that I have to follow if one of the plants is out of service, or what is going to be the population of the area that is going to be affected if I have a burst in an important pipe. Why do we need digital twins? But we need digital twins because really water utilities and the water sector are facing important challenges. First, the water networks are complex systems and they have aging infrastructures. That for sure they are going to need in the future a big amount of money in order to replace and renew all the infrastructure, and we have to be very efficient selecting and choosing the first ones that we are going to replace. On the other hand, utilities are facing constant pressures regarding operational efficiency, cost reductions, regulatory compliance, and why not, evolving customer expectations. On the other hand, we have also workforce challenges because there are a lot of experienced people in the utility that are going to leave the utility because they are going to retire, and utilities are going to lose this knowledge. So we have to do something in order to retain this knowledge and democratize this knowledge that nowadays is concentrated in few people that are going to retire. We don't have to forget climate change because climate change is impacting our activity throughout water scarcity and floods, and for sure utilities are going to face in the future more and more emergencies, and we have to be prepared and ready to manage them well, because water is an essential service and we have to guarantee water 24 hours regardless the situation. So what will we need for developing a digital twin? In this slide provided by the Digital Twin Working Group, we can see very well the components and the things that we need for developing a digital twin. First, of course, we need data from the real system. This data can come from sensors that we already have in the network, or new sensors that we have to install. These sensors have to send information in real time because the digital twin has to be paired continuously with the reality. We need also information from the business applications that utility already have implemented, like GIS or CMMS. And once we have all this data, what we need is a data integration. We need a system, a platform, where we can concentrate all the data coming from the different sources. Then the next step is to have models, simulation models, because the digital twin has to simulate what's happening everywhere. And in this point, we can use data-driven models, AI models, or also physics-based models. I have to say that for water distribution networks, hydraulic models that are deterministic models really work very, very well. And finally, we need a visualization, a customized visualization in order to get the insights and also to be able to interact with the digital twin in order to make actions and improve the behavior of the real system. In terms of the journey, according to our experience, this is the journey that we think an utility should follow we have distinguished two phases. In the first phase, the goal or the objective is to create a solid IoT infrastructure that make possible to simulate the network in real time. For that purpose, as I said before, we need first to sensorize, second, to deploy a data-centric platform that integrates information coming from sensors of other sources. Next, to develop a model or simulation model that is connected with all the sensors. Next, to develop a customized visualization. And finally is when we will have a digital twin that is able to reproduce the behavior of the network. This is the first step, and when we achieve this first step, we can jump into the second one, where the goal is to add collective intelligence to the digital twin in order to make it smarter. That means that the digital twin, if we add algorithms on the top, could recommend the best actions to be done when something happens in the network or according to our objective. But it's very important to highlight that we cannot go to the phase 2 if we don't go through the first step. It's true that in the last years there has been an increasing interest on developing and having digital twins. Indeed, in this slide, we have represented some utilities that have today a digital twin at a scale for water distribution network. We have highlighted Valencia. Valencia probably was one of the first utilities in the world to have a digital twin. Indeed, this digital twin has been supporting the daily operation for more than 15 years. I know very well this project because I worked in the utility of Valencia for more than 15 years as head of water network control. I led this project, and I know very well firsthand how useful and valuable can be operating the network having this tool as a decision support tool. And in the map we also see other utilities that right now have a digital twin, and I have highlighted Brabant Water in the Netherlands because it's the use case that we are going to present later, and I think it's a very good case because it's really a very huge network, so I think you will enjoy the next presentation. In terms of uses, a digital twin can be used for the daily operation and planning. For the daily operation, here I have highlighted some of the benefits that we could have. The first one is to have a great understanding about the performance of the network, because we can estimate the value for not telemetry points. That means where I don't have sensors, I know what's happening. Thanks to the fact that we are simulating, and we can calculate also parameters that are very difficult to measure, like water age or trace. We can detect hidden anomalies or failures. This is very important because the aim is to detect as soon as possible in order to fix them before they become a big problem. We also can use the digital twin as a decision support system for emergency response. As I said before, what's going to happen if I leave out of service a drinking water treatment plant or an important pipe? For sure, we can plan the best day and hour to perform their water operations. Sometimes we have to do, it's not because there is an emergency that happens, because we have to leave out of service because we have to have works, or we have to do works in the network. We can plan the best day in order to avoid disruptions to the people or to the clients. And finally, we can train new operators or new people that are joining the utility, like a live flight simulator. And regarding the planning, with a digital twin, we can do the traditional tasks for planning, like assess network requirements, define the replacement plans that I said before, that they are very important because we have aging infrastructure, and determine the new infrastructure needs and how they are going to behave when we put in service into the water distribution network. So we can determine the commission stages that sometimes is difficult to do it without this kind of platforms. Finally, regarding the challenges, according to our experience, I think we have highlighted here the most important one. The first is to define a clear business case and objectives. What do I want the digital twin for? Second, it's true that developing a calibration or a calibrated simulation model is also a challenge. Data silos and quality is also a challenge because Sometimes we have the data but it's not accessible, and also we have the data but it doesn't have the right quality. And also people engagement and adopt of this new technology because in the end they are going to be the users and they are going to adopt this kind of solutions. And finally, talking about lessons learned, I will highlight first, keep it simple and focus on your main challenges. The digital twin can be scalable, so this is very important. We can start with a very little objective or a few objectives, and after that, when we achieve it, we can add much more capabilities to the digital twin in order to make it grow. Data quality is key, so it's important to preserve it from the source. It's true that the digital twin can have algorithms in order to filter or clean the data, but the most important thing is that the utilities, we have to try to preserve the quality from the source, trying to maintain very well the sensors and trying to store data with good quality, because in the end the result is going to be better. It's true that implementing a digital twin requires a new innovative culture, because it implies another way of working. And finally, the most important thing is the digital twin is not something that is going to replace people, it's something to empower and enriches people's work. And from our experience, what we have seen is that people can learn a lot using a digital twin, and they are better professionals after using it and after having all the insights provided by this tool. So thanks for your attention.
Thanks, Pilar. That was really good and very insightful. And welcome, everyone. It's really good to see we've got a really good number of people joining from Asia Pacific. I have the pleasure of running the SWAN Digital Twin Working Group for Asia Pacific with David Moore from Wouter, which is really useful and helpful for us because we get to learn more and more about what utilities go through. And digital twin, as Pilar said, there's a lot of definitions to it and what does it really mean for many people. I thought what we do today is bring it to the Asia Pacific context. And I will do this through what we did in the end of 2025. We all got together in Sydney for this one workshop, and we tried to really answer a lot of these questions about digital twin and how do you get started and what are the issues and what are the problems, why does it fail sometimes, and we got all really good results from around 25 or 30 people were at this round table, and we were a mix of consultants, technology companies, and of course water utilities from just really all around, which is really good, a really nice mix, and we've landed on some really good results. So what I will do is walk you through this. The way we did this is we've built a funnel, which you'll see in the next slide. Basically, it's a really simple way to look at this, and I'll walk you through it. So basically, when we start looking at this, the headline story usually is all you heard is real. Digital twin and water is definitely growing fast, and now with AI surfacing back up again, it's just becoming more and more fast growing in all of our region. There's genuine interest in understanding what does it look like, and you hear about it, like I said, in every water utility in Asia and Australia, New Zealand, and even Pacific. So we've got different ways to look at this. So one way the sector has come to picture this is, and it's a view that crystallized in our roundtable in the Sydney forum. We looked at it in four kind of stages, really. One, it starts with the interest. So you see the vision, the board buys in, or the executives, and then a line and the strategy. So a lot of organizations are there. Then it comes to the pilot, so a proof of concept, usually a treatment plant or one part of the network, and then fewer really makes it here, but many do as well. Then you get to the connected live model, kind of the one that Pilar was describing, a twin that actually fed by current data, kept up to date, not one-off snapshot. So of course, as you can see, the funnel now here narrows, and finally you get operational at scale. So that's where operators really actually rely on it in every shift to make some really decisions there. The last box obviously gets really narrower, so very few initiatives reach there. And so what is going on here? Like that's kind of really what we wanted to explore as part of that roundtable. So one of the things that we've realized is that what we call the data depth. It's a concept of where a lot of utilities do have good data. Data is not necessarily the problem, but it's not necessarily consistent. It could be an incomplete asset records, inconsistent capture, and basically there is no single source of truth. And so the twin inherits that mess, and it actually starts showing once you start building it. The second one is, and it's similar again to this, there's a lot of AI conversation, of course, at the moment, and it's kind of similar. Everybody wants to pilot things. And so the twin gets funded, projects actually start seeing the light. There's a pilot here, and then the pilot ends, and then there is no owner, no budget line, no team. It just stalls. The third one is actually quite interesting. We've heard from the room that people and trust is a big part of it. Operators won't act on a model they didn't help build and they don't believe. So the room was really empathetic on this. The technology is really hard. The hard part is something we've also agreed on, and people, culture, and trust are really also hard to gain, especially in this kind of space. And then the fourth one was quite the killer, really. So no decision is served. So at the end of the day, you want to try and build, obviously, a twin that does help you with your decisions. So, and that's probably the end of like what we're trying to build here. So where it became really encouraging, and we all were in agreement, really, is not waiting for the data. It's actually kind of quite the opposite. Where we all agreed is start now with what you have. Begin with a small targeted use case. Don't go like enterprise-wide rollout, and make sure you build the capability by doing and not by planning. So while you're doing it, make sure you're building your data foundation. Treat data strategy and governance as your product and not as an afterthought. Absolutely from the beginning, make sure you define a very clear use case that is tied to a decision that will be used by your operators on the site, really on the ground. And then probably the last thing I want to talk about in this slide is that if there's one idea that the room kept coming back to is readiness for digital twin is less about the perfect data or the unlimited budget, really, and much more about clarity and purpose and willing to start. So that's kind of where we were going with that. And then if you, sorry, I lost my, yeah. So on the next slide, what we want to do is look at APAC and some of the challenges we're going through here for scaling the twin. First, fragmentation. We have a handful of large capable metros. So if you talk about Sydney, Melbourne, Perth, Auckland, and a few other big ones. And then we've got a very long tail of small, rural, Pacific kind of island utilities. So a twin designed for a big city network simply does not drop down into a small district council. So the one size does not really translate. Second one, in this region, again, climate is forcing function. So we've got drought, flood, cyclone, and twins here can't justify themselves on efficiency only. They have to earn their keep on resilience and answer questions of like what if analysis when the next event hits. Again, speaking about the small utility constraints in the regions, different regions really, small team, smaller budgets, and then the data is just not big enough for that. And the last one is there's a lot of infrastructure spend. There's a lot of infrastructure investment. I'm bringing one of the examples here. So Brisbane 2032, but there's also like lots of infrastructure spend and digitization programs as well. So when we talk about scaling in this region, the binding constraint usually isn't the ambition itself, and it isn't the software. It has to do a lot with data maturity, team size, and then just being really clear on it. That is pretty much what I had for us today in this section really, and I will pass it now to the case study. Thank you.
Yes, thank you. Thank you. My name is Wouter Huisman, and I will take you along with what we are doing within Brabant Water, a Dutch utility, and how we are implementing a digital twin over the last years. Pilar already showed the theoretical framework, and I will dive more into the how. Just to give you a short overview, our utility is in the Netherlands, in the south of the Netherlands. And to give you an idea of the size of the utility, our network is about 20,000 kilometers long. We have about 1.2 million supply points, and our production of drinking water is 2 million cubic meters, 200 million cubic meters a year. So that's more or less in numbers our utility. And on the next slide, we will have like the overview of our service area. And what you will see is that our area consists of a couple of bigger cities, which are really urban, and also a lot of rural areas. And this also defines the layout of the network. And our main source of drinking water is groundwater, so we distribute the water quite locally. At the beginning of our digital twin project, we started off with, why should we implement a digital twin? What are the challenges that we face? And this was also already a little bit in the presentation of Pilar. But what we see, we have also in the Netherlands, which is known for a lot of water, we have also hot summers here. So we see over the last 10 years that our water system is out of balance, that we also have limit to the sources of drinking water. What we others see within the company is a lot of people retiring, so a lot of knowledge also leaving the company. Another big challenge is that the whole world is digitalizing, so also we as a company should get along with that. And what we see is that we have a shift in our energy sources, so a shift more to electricity, and this means also a lot of work in the underground, which will also affect our drinking water network. So these were the main challenges to start, and we started this program in by the end of 2021. And what we said at that point, we need to think really, what does a digital twin mean for us? So what we decided to do is to first start and make a blueprint, and that's where we started to work with SWAN-Xylem. But before we really started implementing, we said, okay, we take a year to really think about what does a digital twin mean for us on the technical aspects, but also on the organizational aspects. And with that plan, that blueprint, we went to our board of directors. And then in 2023, we had a unanimous go for the start of the project. So from 2023, we started tendering, we started setting up the digital twin. And at this point in time, we already have installed a lot of parts of the digital twin, but we are still working on it, and also getting along the line new ideas to extend the digital twin. So starting with the blueprint, we also set like the goal of the project. And that's on the next slide. I think that's what we want to have, the real-time hydraulic model of our distribution network. So that was the goal that we set, and we wanted to have that. We had a company-wide program ending in 2025, so that was also a really big dot on the horizon when we started, that we want by 2025 have a real-time hydraulic model of the digital twin. And this digital twin is a means in order to get data-driven working. Also in the blueprint, we set a clear scope, and this is also important because, of course, you can make a digital twin of all kinds of aspects of the of systems, but we said we want to focus on water flow. So we set these 4 items that we said, okay, this will be define the scope. So what we want is real-time monitoring. If something goes wrong, we want to detect the anomalies. We want to be able to simulate scenarios, and we want to know where water is leaving the network. So we call that consumption patterns. So this is what we started with. And how did we set up the program? In the end, we want to have data-driven operations. That's what we want. So that's what you see here in the top of the pyramid, data-driven operations, where the digital twin is a means in order to do that. And how did we structure the program? At the bottom, you see the assets needed to collect data from the network and from water leaving the network, smart water meters. All this data needs to be collected, needs to be organized, and that's the data platform. And in the data platform, there are also hydraulic models. Based on all this data, you will generate information and present this information in dashboarding. And with this dashboarding, you give the operators the possibility to take action and to make decisions. So that's the data-driven operation, so that we make decisions really based on the data. And I want to take you quickly through all these aspects. And we start off with the assets, the sensors, and the smart water meters on the top. On the bottom of the pyramid. The smart water meters, those are on the next slide. Yes, we want, as I said, we want to know where water is leaving the network. So for us, this is quite new. We didn't really have smart water meters in our network. So we have a program on installing smart water meters, and we focus for the digital twin on our larger customers, so that we know as they use the majority of the water, so that we know when that water is leaving the network. The other part is the sensors. We're setting up flow meters in the network. You see that on the right in the picture, and pressure sensors to get information on the data flow and the pressure in the network. And on the next slide, I will show how we are going to set this up, because that will come together in the data foundation. This is the data platform, and we're also setting up a hydraulic model. We have 21 independent areas. You can see this here by the bigger white lines. Those already existed, but with this program, we are cutting this up to 100 DMAs. And the DMAs get their information from the flow meters that we are setting up. So we get a view 5 times smaller than we had. In order to get this information, we connect all the sensors in the network with the platform. And for us, it was important to get the data directly to the platform. So no in between platforms. The data is flowing directly into the network, and we choose to use the NB-IoT technology for that. So the sensors and the smart water meters are bringing the data directly to the platform. But also we have other sources that we integrated with the platform, such as our GIS or asset management system, and this is also on the next slide. Our GIS or SAP, where all the information of the hardware is. And also by Osisoft, this is our information from our SCADAs, in order to get also the information and data from the pumping stations connected to the digital twin. And then from the next slide, we get from the data foundation, all data is coming into the platform. We will manage that there and bring it together, and then bring it to the dashboards, where you really can set up the dashboards. We'll have your digital twin and the different applications in this platform, but I think this is also in general. So that's the data science tooling I was talking about, and those are the different applications that, for instance, are used in our control room and also by other parts of within our organization. But I think it's best to show it in a quick demo. So I have made a video, and also the platform is already developing. But here I want to show some small business cases. This is what you see when you open the platform. Here you see a smart water engine where you can manage the data and also access the applications. And for instance, we have a dashboard where we have a quick overview of the actual situation in the network. So here we see for each area the total inflow, the actual total inflow, and the lowest pressure in that area, so that we have a quick overview that we can see, okay, what's the actual situation in this area. What was new for us is more the SCADA-like view, schematic view. We as distribution people were not so used to this, but this also gives us a quick overview of the actual situation and gives us also the possibility to simulate. You also can switch to a geographical view, what we do a lot in our control center. And here I will set up some scales, and then I will do a quick demo. And it's quite an obvious demo, but it shows how easy it is to do hydraulic simulations. And in this scenario, we will close a valve. We will go to a street that is on an end, a pipe that's on an end. So if we close the valve, you will see that there is in the end no pressure. But before, we had a team with hydraulic experts, and if there were works and we needed an analysis, you had to ask the team to do an analysis, and that could take quite some time. And now we have set up a control room where the people in the control room can do quick simulations and get a quick overview of what's going on in the network, so that they also can level with the people in the field, help them, and have the overview of what's happening. So I did here a simulation where the valve is closed for this pipe. And if we zoom out, you already quickly see the red area. So it's meaning that there is no pressure in this area. So you have a quick overview here. And maybe we can go to the next slide. I will dive a little bit more into the benefits and the data-driven operation. So we have this control room that's doing the data-driven operation, and we already see these benefits, because with all these extra measurements and tooling to do quick analysis, we see that we are becoming in control. We see way more in the network. We also start to compare areas so that we can see, okay, what are the areas that are performing well and what are the areas that are underperforming. What we also see, especially also in our control room team, we have a lot of new staff, but with these kind of tooling, we can really help them do their work, and also help them to support our mechanics in the field, to give them overview. So also we have a lot of young mechanics, not a lot of experience, but with this help, they can very well do their job. And what we also see that a lot of new colleagues are coming into the company with new skills, especially on data management, working with data, working with large set of data. So this is also bringing a lot of new skills within the company. And as data is flowing through the whole company, for instance, for smart water meters, we have to work together, where we maybe before were working in silos, like the production department, distribution department, consumer department. We were in silos, but now all these colleagues are working together on a project, and that's very nice to see. And with the data, we can also bring new services, maybe alert people when there is a leak at their premises. So that's also new for us, that we can deliver new services to our clients. So these are the benefits we see already, and we are still very at the beginning. And the lessons we learned is, to really take this step forward. You can sit hours and hours on business cases, but it's really on the additional value that you're bringing in and the different way of working that you're bringing into your company. And in order to do that, two things are very important. That's ownership by the people in your project team, but also by the board of directors and the managers, that they say, okay, we are making this step towards data-driven operations. We take the ownership, we will manage that, we get this done. And the other thing is, for all the technologies, that you need good partners and really work together, because it's still something new. So you have to give each other the space and really have a partnership in order to progress. So those were the main lessons learned. And if you have any questions, I would love to see them in the chat. Thank you.
Great, thanks, Wouter. And thank you to Pilar and Asem as well for their presentations. Pilar, I see you've been busy in responding to some of the questions in the chat, and I hope they're satisfactory. And because I see there's none outstanding at the moment, I like to ask a question, and it's to sort of more in the context of APAC utilities. And my question is around how can utilities balance a traditional ROI-driven business case with harder to quantify benefits, like those intangible benefits that you get from a digital twin. So I like maybe Pilar and Wouter, with your lived experiences at Brabant Water and Global Omnium, if you can talk to some of those, harder to quantify or intangible benefits.
Can I go first, Wouter?
Go ahead, please.
So, thanks, Kevin. I think it's a good question. It's a question that a lot of people ask a lot of times. It's true that sometimes it's difficult because of the kind of benefits that we can achieve with a digital twin. For having this return of investment, I think we have to make sure that we know the benefits that we want to achieve, and also the baseline that we have to compare with. And sometimes it's not easy. If we are going to achieve tangible benefits, like for example, I want a digital twin for reducing non-revenue water. You can measure the water that you are saving. Or I want a digital twin for saving energy. You can measure the energy that you are saving. But even in this case, it's difficult sometimes to compare with the baseline. Because what would have happened if I hadn't had a digital twin? Probably your level of non-revenue water will be greater or higher than the one that you had before implementing this technology, and the same thing with energy. But when benefits are tangible, it's easier, but the digital twin have other non-tangible benefits, like for example security, or trying to democratize the knowledge, because it's concentrated in very few people that is about to retire and leave the company. How to measure security? How to measure we want to have a resilient system? So this is difficult to measure sometimes, and in this case, what we would ask is, what is the cost of not having a digital twin? Probably the cost is managing in a very bad way an emergency situation, or probably losing a great knowledge that right now is in the company. From my experience in Global Omnium, I have to say that we had challenges very, very close to those that Wouter have in Brabant Water. In our case, very key people in the company were about to retire. They knew everything about the system because they were working for more than 40 years in the company, so they knew how to manage every emergency situation, but those people were about to retire and new people joined the company. It's when we decided to have a system that could help us to learn everything about the network very quickly. And I have to say that in 15 years we did a lot of things in the network because we planned a lot of new infrastructure that should be connected with existing ones. And in 15 years we planned everything with the digital twin and we didn't have any disruption. And I'm totally convinced that things would have been very different without having this tool and without having the experienced people that work in the company. So this is, for me, the most difficult thing to evaluate.
Yeah, I can add to that. I already showed a little bit the benefits that we already see. I see also a question by Tristan on how did it change the workforce. What I see within the company, one of the challenges is retirements and knowledge leaving the company. And what I already have seen during the project over the last 4 years, I see the company changing. Like a lot of people are retiring, so we have a lot of young people now within the company, but it's also hard to get the right people. So having a project like this, we really have people who want to join our company and also to work on this project or to be involved in this project. So this also really helps to get the right people. And I see also a shift where maybe 10, maybe 5 years ago, a lot of colleagues were working, for instance, with Excel. We see now a lot of colleagues having a lot more skills on data science and really approaching data in a different way. So I see already this shift within the company and a whole different way of working, where we used to work more on experience with very experienced mechanics, maybe over 30 years of experience. They know the area, they know exactly everything. But now also to get new mechanics, they only have a little experience. And with this control room and the team that's 24/7 available, we can give them the support so that also at night, when they have a complicated situation, that they have the support, that they have the overview, and that they have to, well, they are able to call somebody who can do some simulations and say, okay, it's best to close these valves and not those valves, because then not too many people are affected. And also being able to do these simulations, it gives also a lot of speed. As I said, like we had a hydraulic team and we still have it, but those people, if you want to do an analysis, most of the times it took like a week for you having your answer. But now we can do that just within minutes. So it gives really operational, a lot of speed and a lot of data, and that assures you to make the right decisions. So that's what we already see, and this makes that we are becoming from really reactive to more proactive, and that's very valuable.
I think an extension to Tristan's question, and I think I'm noticing one other in the chat, and it's to do with sort of the workforce is when the platform in the control room falls over, so for whatever reason it breaks or is not available, what sort of redundancy and fallback strategies is there? Or because I think the question is sort of centered around if there's an over reliance on the digital twin and there's no sort of first principle understanding of the network, how do you consider that challenge?
Yes, well, yeah, there is a part, if you set this up, that you become reliant on the system. So we have all kind of checks, balances in order to do that. But if you go offline, there are also we still have our GIS offline, still also have like the knowledge. But then, yeah, you get more in a crisis situation where you don't have like this fast way of deciding. So that's more of a fallback scenario that we have at that time. But as we are a critical infrastructure, yes, we as a utility are also really making plans on what will happen if we have like a week no power, for instance. So we have plans for that, but then you get in a whole different situation. I think digital twin is really for your day-to-day operation and gives you big advantage in your day-to-day operation. But at the same time, of course, we are aware of this dependency on the digital twin, and also having backup plans for that. But then, well, in that situation, you will lose your ability to make quick decisions. Then you have to go to your offline systems.
Yeah.
I would add something, Wouter. In this case, the digital twin doesn't work at a black box. So I think it's very important that it's not something magic that you put something and you get the answer. And this is what I said, that this tool empower a lot people's work. Why? Because they can experiment a lot with the tool. So they can use the tool in the daily basis, but also they can learn a lot, because you have like a platform that is telling you how the system behaves everywhere, and you can experiment. Let's see what's going to happen if I leave out of service this thing. What would I do? And you can start learning and doing so. I think in this case, this tool doesn't work at a black box. It works like also a training tool for people. In fact, in Global Omni, we also use it for training operators in the control room, because sometimes if you have people in the control room, they know very well how to manage the emergency situations if you have experience before. But it's impossible to experience all the emergency situations, because there can be a lot. So with this platform, making a similarity with a flight simulator, people can be trained with the digital twin in trying to see, imagine that something happened, how would you act? And they can learn and learn. So it's not, I think here the dependency of having electricity or power is not as higher as, for example, with other tools that work as a black box.
Yeah, thanks for sharing that. I'm mindful of time, and I know, Asem, there hasn't been a question for you, but I suppose a simple question from me is what's the first step you could take if you're a water utility with this in mind, with this ambition? What's a practical first step that they could take?
Yep, I would have touched a bit on that, but basically try to really find a use case for it, regardless of how big or small it is. Make sure you've got a really clear use case for it, and you saw the presentation from Brabant Water as well. Like, they are very clear on what they want. They've got their pyramid. They've got exactly what they want to achieve. So it can be big, it can be small, but like we said in the SWAN workshop, is get started. Don't wait for the perfect use case, don't wait for the perfect data, but as long as you've got like a use case and an alignment from the team, then just go for it.
Great. And I think we're pretty pressed for time. So Amir, there's just a bit of time for you to
let's just take this quick question from Janae in the chat. I can read it. One major issue to move from pilot to live model lies in the fact that while the pilot can be led by the techs, ops, or asset team, the live needs to involve the 3 teams. Any comments there? It's like, how do you get multiple people to use a pilot?
Yeah, well, what I can say to that is also that you don't only think about the technical side, but also on the organizational side already from the beginning. And that's also what we did in the blueprint. Who are going to work with the tooling? For who is the data important? And what teams also do you need in order to analyze the data, keep the data flowing. And that could also be new teams. In our case, for instance, we now have a team, what we call the IoT data management team, a team really responsible, and it also takes effort and time in order to keep this data flowing. And also maintenance of everything that you're going to set up. All these sensors also need maintenance. So you already from the beginning, you have to think about this and involve these people in what you are doing, and that will also help. Well, then they are involved in part of the project and also take ownership on making it work.
Yeah, Wouter, I was going to add, so that question really ties in with the other questions we've had is, talking about taking the first step. Part of taking the first step, I would say, is getting alignment across your tech, your cybersecurity, and your ops teams, right? Because the ops team might have identified the opportunity to start small, but then you have to consider those cybersecurity considerations, and you must speak to your IT and OT architecture teams to really understand what's their comfort level with respect to IoT devices, with respect to, what are the critical infrastructure that they need to connect with. So I think this is a really good question that ties in all the questions that we've had, is that the first step, you really need that internal alignment to get started.
And we took the time to make a blueprint with all these aspects, technical, organizational, security, and maintenance in there, so that you have, all this tied together.
And just adding, if we didn't get to your question, we'll follow up with you, just due to time. And last but not least, just a very brief SWAN update. So for those of you who don't know me, my name is Amir Khan. I'm the CEO of SWAN. And just this past week, we held 2 workshops at Singapore International Water Week. One was a SWAN India workshop focused on adapting South Asia's water systems in the digital age. And the other was a SWAN APAC workshop focused on transforming digital water for shared progress. So here you can see some of the nice photos. You can now access all the presentations and photos on our website. And it was really inspiring because we had utility speakers from 11 different countries and covered unique formats like utility reverse Shark Tank, and a lively debate on whether AI is really a game changer or costly distraction. So check that out. And save the date. SWAN conference is coming back to Europe. We'll be in Porto, Portugal from May 18th to 20th. So we're now getting this in order. And if you're interested in getting involved, like joining our planning committee, please reach out to me. Registration will be opening soon. And I just want to thank all of our speakers again, to Xylem View, our partner. And maybe Kevin, you want to say some closing words?
No, I thought you did a fantastic job, Amir. But thank you everybody for joining. I think we had a world record, or close to a world record, for the number of webinar registrations for a SWAN forum. So let's keep it up and hopefully see you guys at the next one.
Thanks everyone.
Thank you.
Thank you very much.
Bye bye.
Thank you.
Bye bye.